Anyway, we'll begin to proceed with the next topic that we'll begin to deal with, which is the program evaluation and review technique. This is a PERT analysis that we'll begin to deal with. When we say PERT, let us actually define what is PERT. So when we say PERT, that is definitely, I'm so sorry, what happened? Okay, so for the PERT chart, that is known as the Program Evaluation and Review Technique, which is a statistical tool used to plan, schedule, and coordinate tasks within a project. And that focuses on identifying the minimum time required to complete a project by considering the uncertainties and variability in task duration. It uses three estimates, which is the optimistic time, which is known as O, the pessimistic time, which is known as P, and most likely time, which is known as M. So all you have to do, there will be a structures of step. There will be a specific steps that you will begin to follow as you go through with the process, and we will begin to deal with that later on. So for this one, for the program evaluation and review technique, the optimistic time is also known as the shortest time which requires to complete a task. For the pessimistic time, that is the longest time period of the year, longest time required actually. And for most likely time, that is the best estimate for each task duration. Using this PERT, it will calculate um, the expected time using the given formula that we do have right here. So for the given formula, this is somewhat easy class because of course there will be a given formula here which we will be going to follow, which definitely um, this one using the formula, the O optimistic time plus the 4 times the most likely time plus the pessimistic time over the 6. So that's how you will deal with that. And we'll begin to deal with the calculation because there will be a lot of calculation that will happen for this. And there, for the PERT chart, that contains of three different project, which is definitely, let me just, I'm so sorry, what happened to this? Here, let me just work on this carefully. Okay, so I guess it's all right now. Okay, all right. Okay. Anyway, we'll not bother with that one. Hopefully that it is clear in your end. So for the three different time estimates for the project, the shortest possible amount of time each task will take, the most probable amount of time, and the longest task might take if the things don't go as planned. That is the um, chart contains definitely. And for this one, per chart, circles or rectangles, or known as the nodes, represent project event or the milestone. These nodes are linked by vectors or lines representing various tasks and their dependencies. So allows managers to evaluate the time and resources necessary to manage a project. So you can make using various types of software, including Microsoft Excel or any programming languages. So a quick background for this one. This is we're first created by the U.S. Navy's Special Project Office in the 1950s to guide the Polaris nuclear submarine project. And then here then the effective for large and this is the advantages for this is effective for large complex project, helps in risk assessment through multiple time estimates, identifies task dependencies and critical activities, and useful for scheduling and resource allocation, and supports what-if analysis for project planning. So for the disadvantages for this can be time-consuming and complex to create, highly dependent on accurate time estimates, less effective for simple or repetitive projects, and needs frequent updates and adjustment. And for this one, we have the specific steps that we have to follow, which we have to define the project and its scope, identify the task and the milestone, determine the sequences of their activities, estimates the duration of each activities, and then um, develop the PERT chart, identify the critical path, and calculate the project duration statistics, determine completion of probabilities, and update and monitor the project. So for this one right now, for identifying, for defining the project and its scope, this is the starting point where you identify the overall goal and purpose of the project, which you then you have to determine here the desired outcomes, the deliverables and boundaries of the project, like what is and isn't included into that one. So in this category, define the project and goal and break it down into tasks that must be accomplished to reach that goal. So for this one, um, here then, define the project's end goal and break it down into tasks. So there will be a breakthrough for this one actually. So um, for this accordingly, we'll begin to deal with that in a step-by-step manner actually in our calculations, but I will begin to make it easy for you so that you can easily identify how does it work in the future as well. So for this right now, identify the task and milestone as well. You'll need to identify every task required for the project and organize them logically. This task will lead you toward achieving milestone, which are major progress points. This step breaks down the project into smaller tasks or activities. You also define milestone, which are significant checkpoints or markers that indicate key achievement. So for this one, there will be identifying the task and milestone in a step-by-step manner. But in our example, I will make that easy for you so that you could somewhat identify or achieve the answer um, that easily. Then, determine the sequences of activities, establish the dependencies between activities. For example, some tasks can be started only after completion, while others may run concurrently. So that is somewhat basic. This step involves figuring out the order in which tasks should be done first. Some tasks depend on others being finished first, while others can run in parallel. So because in our task, actually, for example, you're doing a lot of tasks, so definitely it must be a step-by-step process. If there will be a lot of dependencies for that, you will have to check what is the suitable one that you can go next. So basically, we'll begin to identify that as well later. And for estimate the duration of each activity for each task, you'll need to estimate the duration. PERT uses a three estimate, which was mentioned, the optimistic time, which is the best case scenario, the pessimistic time, the worst case scenario, and most likely time, the most realistic estimate. Then you predict how long each task will take to complete. The three estimates help calculate each task expected time with a given formula that I was able to give you earlier. And this weighted average gives more balanced prediction than just one estimate. Afterwards, estimate the duration of each activity by calculating everything. So use a 3 point estimation for each activity, optimistic, most likely, and pessimistic time. So you really have to get the expected time accordingly using the formula, the O plus 4M plus P over 6. And for the variance, the formula is P minus O over 6 squared. And the standard deviation will be P minus O over 6. And a PERT chart is a project flow chart that shows tasks as nodes and relationship between them as arrows. This helps you track which tasks depend on others and how they fit into the timeline. So the PERT chart is a visual tool that shows how all tasks are linked and which depend on others and how they fit into the timeline. The PERT chart is a visual tool that shows how all tasks are linked and which depend on others. It is actually essentially a flowchart that helps you see the entire project at a glance. Next, the critical path is the sequence of tasks that directly affects the project's duration. Any delay in this path will lead to a delay and the overall project. So to identify the critical path, you'll add up the expected time for each path of task. The longest path is your critical path, which helps focus attention in the most time-sensitive parts of the project. Define the minimum time required to complete the entire project. If any task that the critical path is delayed, the whole project will be delayed as well. So definitely, since it is a step-by-step process, and there will be um, specific calculations or process that we'll begin to deal with. Then, calculate project duration statistics. Expected project duration will be the sum of the total expected time values along the critical path. The expected project variation is equal to the sum of variation of critical path activities. The standard deviation of the project will be the square root of the project variance. So take note of those things because that will be the implementations that we'll begin to follow later on. Then, determine the completion probability is you have to use the z-score formula to assess the probability of completing the project by a specific time. Don't you worry because in your examination, I will also give you the z table for that one. So that is the time minus t year project and refer to a z table to find the corresponding probability over SD project actually. So we'll begin to deal that accordingly later. And once the project is underway, you must regularly update the um, PERT chart with actual progress. If task more or less time than expected, adjustment can be made to the timeline and task sequencing. Once the project starts, tracking progress and ensuring tasks are completed in time is essential. If any task is delayed or changes occur, you update the PERT chart to reflect this adjustment and keep the project on track. So this is basically a good thing. So we'll begin to deal with that one by one in a separate video as well. Thank you.